Hi, everyone. I'm Christian from Elon University. I'm very happy to present this paper on behalf of my co-author, Dr. Sham Sunda. And our paper is trying to understand how labeling quality influence users' trust in AI. Let's first imagine we're interacting with an emotion reader AI system, which has been designed to classify people's facial expressions into different categories like happy versus sad. And if the AI system tells you that it has been trained on a sample of label data like this, like all these images are labeled as happy, and this group of images labeled as sad, how do you feel about the AI system? Well, you may take a close look at each of the images, and you find that the first image is pretty happy, which is good, but the picture right below it doesn't seem to be so happy. So the problem in data labeling may make you question how trustworthy the AI system is if it's trained on a sample of data like this. Well, this may be the worst case scenario, as no AI system will be trained on a pool data set like this. But the question is still valid. That is, to what extent people will take a close look at the labeling quality and factor that in when they evaluate the training data credibility and trust in AI. So that's the goal of our study. We're trying to understand how labeling quality may influence users' perception of training data credibility and further influence their trust in AI. And we're also interested in under what conditions this model works by examining two moderators, that is labeling source and racial bias in AI performance. And we did a user study with 430 participants. And we told our participants they're going to interact with the emotion reader AI, which has been designed to classify facial expressions with social media images. And so far, this emotion reader AI has been trained on a large database that has nearly 10,000 facial images. And these images were labeled by volunteers who give tags to each of the images, such as joy, sadness, anger, fear. And so far, there are 500 people participated in data labeling. And then participants were invited to see either a video that is showing how a crowd worker labeled 3 example images through a video. Like in this case, this person labeled the first image as neutral, as showing a neutral facial expression. And for the second image, and this crowd worker also labeled it as neutral. And the third one is a white subject image, and it was labeled as neutral as well. Or they participate in data labeling by themselves. So if they were seeing the data labeling opportunity, but couldn't take any action because they were told this feature is not quite ready for use, they're assigned to the Q condition. If they have the chance to choose whether to label or not, they're in the voluntary action condition. But if they are required to label the data before jumping to the next page, they're in the forced action condition. And after these procedures, they were exposed to the page showing different levels of data labeling quality. So if everything is labeled correctly, they're in the high quality labeling condition. As you can see, all happy faces are happy, all sad faces are sad. But if they're in the low quality data labeling condition, you can see that half of the images were misclassified. As you can see, there are very obvious sad face in the happy category, and similarly, there are some happy faces in the sad category. And after that, we measured users' perception of training data credibility. That is, to what extent they think the training data of the emotion reader AI is credible, trustworthy, reliable, and dependable. And following this, we invited participants to see different types of AI performance. So if they were assigned in the unbiased performance condition, all the classifications were correct. As you can see that all 4 images were labeled correctly. But if they're in the biased performance condition, the AI system showed clear bias against Black individuals. As you can see, their facial expressions are labeled incorrectly, as this happy woman is classified as sad, and the sad man is labeled as happy. Or we also have a control condition showing no performance to our participants. And after this procedure, we measure their different levels of trust in AI by focusing on 3 dimensions of trust. That is cognitive trust, affective trust, and behavioral trust. And here comes to the results. So we found that showing user different levels of labeling quality, it can influence their perception of training data credibility. That is, if they were exposed to a high quality labeling, they're more likely to think that training data is credible, trustworthy, and reliable, which further increase their cognitive, affective, and behavioral trust in AI. And also, we found the moderating role of racial bias in AI performance. That is, priming user the training data is credible is likely to maintain their cognitive trust in AI when the AI shows no performance or unbiased performance. In other words, when the AI shows biased performance, knowing the training data is credible doesn't help maintain cognitive trust in AI. And this finding is interesting, which is good because it tells us that priming users about training data credibility upfront can help calibrate their cognitive trust in AI. However, that's not the story when we focus on affective trust or behavioral trust in AI system. We found that regardless of the AI performance, as long as users believe the training data is credible, they're going to trust the AI emotionally and behaviorally, and that's the trade-off of this new design. In addition, we didn't find the moderating role of labeling source. It means that labeling source doesn't help add values to the perceived training data credibility as long as the labeling quality is clearly conveyed. So we do not encourage AI designers to incorporate this labeling task before users' interaction with the AI system. So overall, our study provides a new design approach. That is, by showing users a snapshot of label data indicating different levels of labeling quality, it can encourage them to pay more attention to training data credibility. And this early communication approach is important because it supplements the post hoc explanation approach in current explainable AI field, which focus on explanation after the AI's performance. And also we found that this approach may work well for supervised machine learning systems because they have to be trained on label data, and it will work very well with AI systems that are trained on clearly defined labels, such as happy versus sad, woman versus man, dogs versus cat. And also it may benefit AI systems that are trained on visual data like facial images. Yeah, that's all of my presentation, and thank you for watching this video. If you have any questions or comments, please feel free to email us, and we look forward to hearing from you and wish you a great time and CHI.